Okay, so now our new topic for today is, if you go to the course website, you will see building tables, okay? So we have seen several examples of tables now, okay? And now we're gonna build more. And part of it is a review of what we have seen, part of it is some new skills, and then terminologies here and there. So all of them will become super useful later on. Okay, so here we provide a review of arrays, but we just talked about it. And just again, remember same data type, okay? And arithmetic is applied to each element individually. They have to be the same size if you want to add things up or take the difference. And then lastly, a column of a table is an array, and then we can do arithmetic about it. All right, so for tables, okay, we're gonna get into more about building tables and then thinking about table manipulations. And before doing that, we need to introduce one more concept here, which is ranges, okay? So ranges, as you can see, a range is an array of consecutive numbers, okay? And just now we made a array, if you remember, 1, 2, 3, 4. Okay, I can use my underscore array and then parentheses 1, 2, 3, 4 with commas in between. I can create an array in that way. But sometimes, like you want to create, like say 1 through 100. Does this mean that you have to type like 1, 2, 3, 4 up to 100? That might sound a lot of work to do. So in fact, there is a handy library or handy function here that can do that for you if you're working with consecutive numbers. Okay, so when I say consecutive, it could be 1, 2, 3, 4. Okay, but it could also be 1, 3, 5, 7, odd numbers, things like that. So as long as they're consecutive and then with the same numbers in between, then you can do this method. Okay, so the method actually is coming from the NumPy library. So it's MP. Okay, so we use MP again, and the method name is arange. Okay, and if you do only one input, it's going to be an array of increasing integers from 0 up to end. Okay, just as an example, if I do mp.arange parentheses 5, then what that's going to do, as you can see from the note, like from the definition here, it's going to start from 0 up to 5, but does not include 5. Okay, so that's the thing important to keep in mind. Okay, so if I do mp.arange 5, it's going to be 0, 1, 2, 3, 4, but not 5. Okay, so that's the case when you only input, like do one input. But this function, actually, you can do multiple inputs. So if you also start, like add a start input, then it's going to be an array of increasing integers from the start value that you choose up to end. Okay, so if I do start as 0, then it's going to be the same as the first version of only inputting end. But if I start with some non-zero value, then I'm going to start at that value and then going up to the value of end, but does not include end. So if I do start with 1, and is 5, then it's going to be 1, 2, 3, 4, exactly the my array that I created earlier by typing out each of the element. You can also do step. Okay, so that's what I was saying, that as long as consecutive numbers, it doesn't have to be like 1, 2, 3, 4, like with only one value difference. You can do 2, 3, 4, exactly, like depending on what kind of thing you want to do. So this will be arranged with step between consecutive numbers. So I will do a demo soon based on this definitions. But just to highlight one more time, the range always includes the start, but it does not include the end. So if I really want 1, 2, 3, 4, 5, I need to end at 6 and then start at 1. Okay. Now, one thing you might notice that here, the third option, if I add the step, I can start to add different increments. So the default of that is always 1. Okay. That's why, like in these two versions here, if we don't specify what the step should be, the default is 1. So we're getting 1, 2, 3, 4, things like that. All right, we'll do the demo in a second, but let me actually ask you to brainstorm this different scenarios here. Okay, I have 4 questions for you on the left. Okay, the notes that we had from the previous slide is kept on the right. So I have 4 questions for you to think about. I would just say, I do want to put you guys into breakout rooms to discuss this. So maybe either you write this down, like the 4 different exercises here, like 0 to 5, 0 to 6, this for in your note, or you can just go to our website and open this slide. And this is, I think, slide 5. Okay. So, so then you will have, you know what you're going to be talking about once you go to the breakout rooms, because you won't be able to see my screen anymore once you're in the breakout room. Okay. So let me stop share here, and we'll come back. And yeah, so for those questions, let me share my screen here. Yeah, so we're gonna keep this here, and let's just talk through this one by one, and then again, the cheat sheet is on the right-hand side. Hopefully it's useful. And then we're gonna go to the demo, right? So for the first one, 0 to 5, anybody wants to just speak up to show what you think we should do in order to get this array?
Would you do np.arrange and then 6?
Yeah, that would do. And if you want to do like super comprehensive, you can do np.arrange 0, because that's the start, right? Comma, and then 6, that will be the end, and then step equals to 1. Okay, but yes, for this case, and I guess for the second case as well, you can just use the and as one input, and then you're gonna get it. Okay. So the second one, I guess I will just answer that quickly. So if you do np.arrange of 7, then this will give you this particular array. Okay, so it goes up to end, but does not include end. All right, what about the third one? How to create this array? 0, 2, 4, 6, 8. Anybody?
Would it be np.arrange 0 to 10 step 2?
Yeah. Okay. Yeah. So Samantha was saying that we can do start as 0, end as 10. Okay, because end again is not included. Okay. And here, because the step size is 2, so we need to specify that third input as well.
Could we use 9 instead of 10?
Yeah, good question. So Juliana's question here is that what if we do np.arrange 0, 9, and then 2? Any guesses here? We're going to do a demo quickly about that as well. But what do you think? Can we also get to 0, 2, 4, 6, 8 by putting the end as 9?
My guess is that it works. I just wanted to check.
Yeah, indeed. Yeah, it is going to work. So if you're going to, yeah, so end again, you just never go up to it, right? Get close to it. Yeah. So if you do 9, I think we will do fine. And then we can also try later, what if I do like 9.5? Let's just see what happens. Okay. But then of course, if you do 10, that will be fine. But if you start to do 11, then probably not, because it's going to go up to 10. You won't stop until 10. Okay. So those are some tricky scenarios. So that's definitely a great question. And what about the last one? Step size here is 0.3, right? So my start, I guess, will be 0, right? My end, I guess, is anything, I guess, greater than 1.2, right? But not as great as 1.5. Oh, sorry, never mind. Let me take that back. I cannot go up to, I cannot do greater or equal to 1.5. Okay, but anything below it, but greater than 1.2 probably will work with the step size of 0.3. Okay. All right, so let's look at those demos that we have in mind, okay? But again, you can always create, I think all of you know by now, you can always create new cells in those Jupyter notebooks and try it out yourself, okay? Like the question Juliana asked earlier, what if we do 9 instead of 10? Can we also get up to 8? That would be a great example that we can try in a second once we go through this one first, okay? All right, first, always around the beginnings, so we're able to get the libraries loaded. Okay, so here arrays of 0 to 6, okay, and we can do NP, so that's answering the first part of the question. The second question, I think, this is just another example. If I want anything not starting at 5, not starting at 0, I can pick my particular starting value, okay? This is going to 0 to 18, if I do 20 and then with step size 2, okay? And here is the demo related to Juliana's question here. If I do 0 as the start and as 21, then I do 2 as a step. So this is the case that it's going to go up to 20. okay? Because the n is 21. It won't go up to, it would only go up to 21, but not 21. Then plus 21 wouldn't be printed because it's only even number. Okay, so this is the case that you can do this. And let me just add a cell. Oops. Oh, sometimes you see, it's very easy to accidentally delete a cell. But anyway, I intended to do a add here. And let's just do 19, okay? Because this is more related to Julian's question earlier. Okay, if I do this, I think it's gonna give us the same thing, okay? Because it won't go up to 9, it won't go to 19, it will go up to 19. So 18 will still be printed, okay? And my other comment just now was, okay, what if I do not do an integer as my end value, okay? What if I do 19.5, okay? I'm still having step size 2. What do you think this might happen? Still gonna get 0, 2, 4, right? Probably up to 18. But what's interesting here is that it starts to have a decimal point, even though all of them are 0. Okay, so I think this is because we are using like at least one of them, either both, or like I guess both, or one of the start or end values starts not to be integer, but just like a double point, then it's just gonna go with the double. Okay, but I guess in essence, it doesn't really make a difference, but then it does show in a different format here. Okay. All right, so with different step size, we can also do 0.1, or like the earlier exercise will be 0.3. Okay. And one last thing I will demo is you can see that, well, we can always assign, like what we had done before, whatever the array that we created to an object, so later we can access it. Okay. So if I do np.arrange 8, so I know it's 0, 1, 2, 3, 4, 5, 6, 7. Okay, so that's my A. Okay, but let me show you one thing. Like say this dot item is a use-for function to be applied to an array. Okay, if I want to access certain index right now, okay, and notice the one that I'm picking is 8. Okay, how many objects do I have here? 1, 2. How many elements I should say? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I do get exactly 8 elements. Okay, so what if now I put 8 in my parentheses? Do you think it's gonna get me 7, the last element? Maybe, maybe not, maybe. Okay, let's see. Yeah, apparently Python does not recognize like this, whatever input as the index. Okay, it's gonna be index plus 1. This is just like some tricky thing here. So what I mean here is that, well, although I'm trying to get the last element and I know if it's indexing, I know it's gonna be the 8th one, but apparently this is because if you remember, the array is always trying to like np.arrange is always starting at 0. So it's always sort of like had a 1 plus, like a +1 index at the beginning. Okay, so if I do want to get the 7th, or like the 8th one, I actually need to do 7 as the index to get the 8th one. Okay, it's a little bit tricky, and I don't think it's going to happen too often anyway, but I do want to show you that this is possible. So sometimes it could get a little bit confusing.
What about arrays that don't start in 0?
Yeah, good point. So I think, yeah, good point. So I think the array, okay, let's do like a B np arrange. Okay, let's try out Juliana's question. Let's do 1, 9. Okay, so we still get 8 elements here. Okay, and my B. Okay, okay. So how about I'm getting 8? All right. So apparently, like it's not really about like the starting value, whether it's 0 or not. Okay, it is like about the indexing. So I know if we do count, clearly this is the 8th element. Right? And I really just want to get the 8th element. But I guess a lesson here is that whatever, when you're using the item function here, and then the index that like the value that you type is index plus 1. Okay, so if I really want to get the 8th one, I have to do 7. And again, this is pretty specific to Python. So like if I do 7 here, I will get 8. Sorry, the numbers are just like a little bit confusing as it shows here, but I think you get my point. That even though you can use item to get each element as you like, but then you need to do the index correctly. Okay, so if I want to get the first one, so maybe easier to think about this. If I want to get the first item, I have to type 0. Okay, just because the indexing works in Python in this way. And we're going to see that later as well, I think, when we're later going to work on particular data frames, for example, and I want to look at the first row, then the indexing actually is starting from 0. So if I want to get the first row, I have to get like 0 row, even though it looks a little bit confusing at the beginning, but I'm sure like as we see more examples and then practice more, we'll get more familiar with this. Okay, sounds good? Anything else? Okay, cool. All right, so that's the ranges. So let me stop recording here for this part. And then we're gonna go to the new topic, okay? The new topic of our table, building tables is more on tables, okay? And we're actually gonna bring an example of Minard. So some of you might know the name, some of you might not, maybe from high school history or whatever history before. And but anyway, we're trying to use this as an example to show more manipulations about tables, and that can go a long way for us in data science. All right, ways to create a table. Okay, we talked about it a little bit, if you remember from last week, that we're creating a table. Well, I guess, well, maybe not when I was teaching, maybe Jason did some, but let's just show you a few ways to do it. First one is the one that we have seen already, table.read_table, and then the file name. That will read a table from a spreadsheet or a CSV file. So most of the ones that we have seen, if you notice like how they ended, like the extension of the file is .csv, okay, comma separated file, okay? You can think of it as a spreadsheet, is just saved slightly different, and that is reading it from a outside source, okay? And we have seen that, I think, most recently with the MBA data set, but soon we're gonna look at the Minard example in a second, and that's how we usually read a table from an outside source. You can also create an empty table. We're gonna do some demos there soon as well. And well, of course, when you create an empty table or like a new table, adding new columns and things like that, make sure that you always assign it to some object, so later we can access to it. Similarly, when we read a table from a spreadsheet, and then we always name it, like say the MBA data set, we just name it MBA. So later, whatever things we do to the table, we just do MBA dot whatever the function that we're gonna use or method we're gonna use, and then go from there, okay? So once we create a new table, the select function, where, sort, and all of the other ones that we have seen can also be used on any kind of tables, whether it's read or like sourced from outside, or if you create the table yourself. All right, so keep those in mind. We're gonna go to more examples once we get cover the basic of the Minard example. Okay, so Charles Joseph Minard, 1781 to 1870, quite long longevity back in those days. So he was a French civil engineer, okay, who created one of the greatest graphs of all time. Okay, especially if you think about back then, people don't have computer. Well, many things are really hard to calculate by hand for sure. But then I should also say that I think back then people are super creative as well when they're creating graphs. And then this is definitely a great example. Maybe later in the semester, we're able to introduce some other examples as well. So for this one, what we're gonna look at is he created a visualization of Napoleon's 1812 invasion of Russia, okay? So imagine he was trying to include all of this information into one graph, okay, the latitude and longitude of each city when the invasion was taking place, okay? Of course, also the name of the city. Also, because it's an invasion like going forward, he was also recording the number of soldiers at each step, but at the same time, also the direction of the march, okay? Moreover, the temperature on the return journey, as well as, well, when each city or how the invasion at each step happening on particular dates in November and December. Just imagine like how much information that graph has to include. And then now let's turn to the graph, which is pretty impressive and really nicely done. Okay, I'm gonna take a pause here to let you take a closer look of this graph just to see what we mean by, well, he was trying to include, if you remember, the name of the city, okay, the date, okay, the temperature, also the number of soldiers, okay, also like we were saying, the direction of the march, okay, and latitude and longitude of each city. So it does include a lot of information, like you can see over here. Okay, pretty impressive, like I said. And I also think back then people were really creative. Now people are creative too, I have to say. But then computing resources really empowered us. But also, I mean, as someone who's been working in this field for a while by now, I feel like sometimes I am a little bit restricted in terms of what kind of plots I can make because of the sources I have, or like the computing programs I have. Maybe I restricted to some degree that, for that kind of data, I'm always going to use this kind of visualization. And I think all of you will gradually get into that as well. But I will also urge all of us to be creative, especially when things are pretty rich in its information. And then we can sometimes think outside of the box of what kind of plots we can do. Okay, alrighty. So just to bring us back to the data source and then think about what we can actually do with the Python here. This is actually, if we load the data, like somebody clean up this data, okay? And then this is a screenshot of some of the data observations in this data set. You can see that it has the longitude, latitude, and the city name. Okay, also direction, whether it's advance or retreat. Okay, and survivors, which is the number of soldiers at that point. Okay, as you can see, well, the survivors, starting from the beginning, right? And then it's advancing, right? And then after the last four rows are talking about retreating. And then the number of soldiers, slowly decreasing. And then in the end, it's probably only about 10%. Okay. All right, so this is the data set if you look at a screenshot of it. But let's go to our demo, which is the second demo here, MENAR example, okay? Notice that here, we're trying to use this to demonstrate like creating tables, as well like using all different kinds of functions that we can apply to tables for our purpose. So this is where we're gonna get started, right? So we load the library, okay? And the data set, okay, it's called MENAR.csv. Okay, so this is, if you now see it more carefully, okay, remember, we're saying that if you're reading a data set from a spreadsheet, you can use this method called table.read_table. In the parentheses, typically is a CSV file that it's, you can download or we provide it to you. And just keep in mind later on for the course project, when you, we're gonna announce that soon, but when we get started doing that, if you're like collecting data yourself or downloading a data from online, then what you need to do actually is to put this, whatever the CSV file that you're gonna have, into the same working directory. And then from there, you can do this table.read_table method in order to read in your own data set. Okay. Right now, all of the data sets we're providing for you. So you don't need to do that step. But then once we get to the step of doing projects, we're gonna do more demos of collecting your own data, putting into the right data directory, and then go from there. Okay. All right, now we save the data, as we know, into the object of MENART. Okay, so this is what we mean, okay? We have the longitude, latitude, city, okay, direction, and then survivors, okay? Alrighty, so let's do a few things, okay? Especially if we're curious about, let me put it this way, there's so many things you can do about this, of course. And I'm not saying that we're gonna recreate whatever the visualization that MENAR did before, but let's maybe focus on some of the questions. Okay, maybe one thing we could do is that I want to know the percentage of survivors, okay, at each step of this invasion. Okay, advancing and then retreating. Okay, if we look at this table, we have the longitude, latitude, probably not really useful for whatever we're trying to do in terms of getting the percentage of survivors. And most likely, if we look at all of the 5 columns here, the survivors column is going to be really useful. Okay, that is giving us the number of soldiers. Okay, and my question is, okay, how can I quickly manipulate this table in some way that I do want to get the percentage of survivors compared to the initial stage of of the invasion. Okay, so if we don't worry about like how to do it in terms of coding, if you just think out loud in terms of answering that question, what we really need to do is that we need to get this survivors column, right? We need to do something about this, okay? And again, it's an array. Okay, once we do the column, it's going to be array. So we're going to start doing certain manipulations about it. So if I want to get the percentages or like the percentage alive, starting from the beginning, essentially what I need to do is that I need to get this column. I need to get all of these values. Okay, I need to, I most likely I have to like take the ratio of each of the item over the first item because that's the beginning stage. Okay, so mathematically, that is what we need to do if we want to get the percentage alive. Okay, we need to get that column. We need to do the division, okay, column like element by element division by the first element because that's the initial value. Okay, so keep that in mind because now we're going to show you how you can do it through Python. But a lot of times you have to think ahead of what you actually want to do with the particular column. And then you're going to design and think about the steps that can achieve that. Okay, so I am now giving you all the goal of creating percentage alive. So we know that that's what we want to do. We want to take the column of survivors. We're going to take the ratio of each of the elements with respect to the first one. So we're able to get the percentage. Okay, so now let's see what we can do, how to do that. Okay, a few things. Well, select. Now just one more demonstration of the select versus column. If I do select, okay, we know that it's going to keep a new, like create a new data frame actually with one column in this case, okay, only the city. But if I do column, if you remember, then I'm returning an array, okay? I'm returning an array in this case, it's a string array because all of them are just name of the city. All right, so back to our original goal, okay? We wanted to create the percentage alive, okay? So between select and column, because remember when we do column, we're able to get that, get that column as array, and that's gonna be a numeric array that we are able to do arithmetic about, okay? So in this case, we better use column, okay? So we're getting an array, and each of the elements is the number of survivors, okay? All right. Okay, so let's get started. Like I said, we wanted to create a percentage alive, maybe one extra column there added to the original data frame that we're able to get that percentage. So what we can do, okay, so first of all, remember the percentage has to be created by each of the item, each of the element in that survivors array divided by the first one because the first one is the initial stage. So we do need the initial one way or another, okay? So the way to do it, as you can see, we do the min.column and then survivors. So that will give me the array, okay? And now this is a demonstration of what we are discussing earlier. If I want to get the first element of it, I can do .item, remember? But then I have to choose 0 because the indexing goes that way, okay? So, and then I assign it to initial size because I'm going to use this object later on. So let me run these 2 lines and show you what I mean. Okay. So we know that the first item is 340,000. Okay. That's the initial stage. In order to get that, we have 2 steps. Okay. First of all, we create this array. And once we get the array, we want the first item. And we know that to get the item, you can do .item. And then to get the first element, you have to use index 0. Okay, so with these 2 steps combined, you're able to get this initial size as 340,000, which is the initial size of the, I think, number of soldiers. Make sense? Okay, so now I have this initial size as a object that I saved with that particular numbers. So I know the entire thing that I need is gonna be the survivor column earlier with the array divided by the initial stage. So I'm getting the percentages here. Okay, so this is the array, final array that we want. Okay, and this is giving us the percentages. Lastly, let me show you one new thing that I think probably new to everybody is if you now have an array that you created, and you want to attach that to your original table, the way to do that is, well, you have your original table, name, Minard, okay, dot. The method is called with_column. Okay, so what that does, and you can see that there are two inputs here. The first one is the name of the column that you want to give it to it. The second is what we just repeated of this percentage calculation from the previous step. Okay, so what this does, as you can see, is that I'm adding a new column called percentage alive, PCT alive. And then that column includes the percentage alive that we are able to calculate. Okay. And notice this is actually also a good reference to one of the earlier questions that we talked about earlier, is that I can always reassign the object, right, with the same name. So if I do this, like Minard and with column, and then now I assign it back to Minard, then my Minard gonna have this one extra column that I want, okay? So this will be the case that maybe later on, I don't want to deal with the original data frame anymore. I always want the new data frame with the new column. So this is a good practice here that I can assign it back to the original name, so I can just work with that. Okay, so let's see what we have achieved. Okay, once we have done that, see the new column? It's called PCT alive. Okay, and each of the items here correspond to the calculated values that we had earlier. Sounds good? Sounds good. Okay, yeah. And then there are some other things we can do, like set format. If you want the format in a percentage format, so now we're like 1, which is 100%, right? 0.5 is like 50%. So you can actually use the set_format function to reformat this percentage alive column. And the way that we do it is called %formatter. This is, again, you probably have to look it up to know the particular input option here. But this is just a demonstration. If you want to put in percentages, you can use this function. And again, this function is being applied to a particular column, right? So you have two inputs in this function, the column name and exactly how you want to format it, okay? And then lastly, if we do one more time with the column, because we never assigned this to Minard, right? We only just did some formatting. We didn't assign it to the Minard data frame, so we actually haven't changed that column. This is just one more demonstration of always make sure that if you do something to a column and you actually want to keep it for future use, you need to do the assignment step. Otherwise, we will never change it. Okay, so let me demonstrate one more time here. If I do assign this new thing to Minard, and then if I do column, oh, I guess it doesn't matter. Never mind. Let me take that back. I guess the percentage format thing probably doesn't change much. This is really just showing us like a way to show the results. But if you return it as a column, which is array, I guess just like printing out either way. In this case, it's mostly just the integer value. Oh, sorry, the decimal points instead of percentages. Okay, but they're the same thing. So, okay, let me take that back. This is just one way to show how you want to, if you do want to make that into a percentage format, then the set_format function will be useful. Okay, let me just like recap, because I know it's a lot going on. Okay, we started with the Minard example. We load the data. Okay, we decided that we wanted to create a new column called percentage alive. And we know that in order to do it, we have to divide each of the elements, okay, in the survival column. We need to divide that by the first element in order to get the percentage. Okay, so that's, well, the goal. And then we show you step by step of how you can do that through Python. Okay, first step is that we actually, first of all, make sure that we do, we choose to do .column in order to get it as an array. Okay. Second, because we need to get the first initial size, because that was the thing that we're going to divide for each of the element, and it's going to be array manipulation, right? So we better get that item first, and the item index is 0, just because Python works in this way. And then we actually want to save it so later we can use it. Okay? And then the third step is that we know that, well, in order to do that array manipulation, we select the column, which it becomes an array, right? And then we divide it by the initial size that we calculated so we can get the percentages. But then of course, we learned something new today. We're able to use dot with column to actually add that new array as a column into the original data frame. The way to do that is that the with underscore column function takes two inputs, the name of the column name, and then whatever the column that you really want it to be. Okay. And we also show if you really want to have a percentage format of showing that column, you can do that. And but also always make sure that if you need to add it back to that original data frame, you need to reassign it to the original name, because otherwise all of the manipulation you're doing is only just with on it, but it's never affect the original version. Make sense overall? Okay, yeah, so this is actually pretty important and useful later on. And I think, again, through lab and homework, you're gonna get more exercise. And don't get frustrated. I think a lot of times it's really challenging to even just think it through what you are trying to achieve. And then of course, to achieve that, you have to synthesize the stuff that we have learned and then figure out the ones that is most useful. And it does take time and practice. So definitely reach out whenever you have those questions, and then we're always happy to help. But like I said, always useful to look at those demos, run it yourself, and then convince yourself why each step works in the way that we want it. And that can definitely be a really good learning material and then learning experience for you all. Alrighty, so try to cover the last topic. So we'll be good to go to the next topic on Thursday. Okay. Oops. Okay. All right. So a few more table methods. Like I said, we have covered a lot, but there are always more to learn and always more to that can be useful. So let's go over some of this. So this is, again, might be a little bit boring. We're going through what we have learned, but sometimes it's a review, like I said, but sometimes it's new. And even if you have seen this, all of them before, it's always good to review some of this because, again, practice makes perfect. So creating and extending tables. Okay, so creating, you can read it from our source, okay? Or when you're extending a table, when we say extending, we're adding new columns. So that is the with column method that we have seen just now, okay? And find the size of the table, okay? So this is really useful. Like once you have the table name, we just use T to represent it. You can use num underscore rows or num underscore columns to get the size, which is the number of rows and number of columns. Okay, number of rows give you, the number of observations in the data set, and the number of columns gives you the number of columns or attributes in this data set. Referring to columns, okay, you're able to do, well, you're able to choose like labels or relabelings or using indices. Okay, for example, if I do T, which is the name of the table that we're working with, dot labels and dot relabeled, we're able to select, if you remember, like choose those columns as well as relabel it into a certain way that you want. Okay, I think in the MBA data set that we have seen, I think salary was probably small letter, and then we always relabel it as a capital letter just to be consistent with the different, like all of the other column names. Okay, and also column indices start at 0. Okay, so actually in Python, I guess anything, the indexes start at 0. So it's always a good lesson to keep in mind. Accessing the data in the column. Okay, so here, just keep in mind, when we do dot column, we're taking this column or label and returns an array. Okay, and earlier, if you remember, if we do T dot select, then it's actually returning into a different data frame with that single column. Okay, but of course, when you do select, you can select multiple columns. So that's another story. But what I'm trying to highlight here is that only T dot column gonna returns it as an array. But then if you do T dot select, it's not gonna return as an array. It's gonna return it as a data frame again, a table again. Lastly, using array methods to work with data in columns. Okay, we can do T dot item, sum, minimum, max. So again, all of the array arithmetic that you're able to do once you turn a using the T dot column, turn a column into array, you can do all kinds of stuff, just like what we showed earlier, like trying to get the percentage. Okay. If you also want to create a new tables containing some of the original columns, okay, you can do T select. Okay, like when you do that, if I want to have multiple columns, I just put all of them in quotes and then with comma separating them. I can also drop certain columns I don't want to work with anymore. And we have seen that, I think, in the lab as well. All right, so let me do that demo now. So I know we do watch the time, but I think we should be able to get to some of this at the least. All right. Okay, so I think, yeah, actually this is new, I think, to most of you. Create a table from scratch, okay? From scratch, like I said, we're gonna use the table parenthesis and then dot with column to create the new columns. So before doing that, let's just say our goal here is trying to create a table of 4 different Vassar dorms, okay? And then also the year of year built for each of the Vassar dorm, 4 of them, okay? So we're creating a table from scratch, okay? So now let's see how we can do it. Remember, each column is an array. Each column of a table is an array, okay? So if we're creating a table from scratch, we're really starting from scratch by creating the array first and then trying to put it together into the table format. All right, so we're gonna start with door names, okay? We're going to focus on Strong, Raymond, Davison, and Noyes. All right, so once I do this, make array, okay, they're all strings, so I put quotes in them around it. And then now I'm going to use this table parenthesis underscore with column. You remember this? The first input is the name of the column that you want. We're just use name right now as the name of the dorms, okay? And then the input, the second input is actually the array that we just created. Okay, so if I do that and assign it to dorms, now I start to have a single column data frame, okay, a table, okay, with only names, okay. All right, that's one thing. And like I said, we also like the year built, those informations is given to you, and then we want to add that into our original table. So one thing we could do is remember with column is always what you can do, right? You can have the first input as the name of the variable, and then the second is the array itself. So let's do this first, okay? So this is, well, if I do dorms dot with column, if I do this and just return it, this seems to give me like a 2-column table, right? Okay, by the way that we're doing it, we already have the name and then we're adding the column of year built. However, this is just to highlight one more time, unless you assign it to dorms, otherwise the new column is not added. Okay, you're really just demonstrating that you can add it, but only if you assign it to, like in this case, the dorms, which is the name of the table. Otherwise, we're just like showing that you can, but it's not being assigned. So in order to do it, okay, always make sure that you assign it to whatever you want it to be named, and then you're able to access it later. Okay, so look at between these two, okay? All right, and then lastly, we know that labels, okay, so labels also columns. So if I want to return the list of the labels of a particular table, I can do the name of the table dot and then labels. In this case, I have names and AO built, okay, so I can know the 2 names if you forget about them, but I guess you can always see it from the table itself. The second thing is what we showed earlier, the number of columns and then the number of rows. In this case, the number of columns is 2, the number of rows is 4. Okay, so this looks, I guess, straightforward enough. But like I said, when you're working with a really large data set, like once you read that into your notebook, and then you have a really large data set with large number of rows and large number of columns, then those labels, like labels method, and then the non-columns and non-rows method will be really useful as well. Okay, all right. One last thing here, let's look at selecting data in a column, and we've been talking about different ways to do that already, okay? And this is just one new demo here. This is movie by year with ticket price, okay, from I think 1990 to 2015, something like that. So let me load that data for you. And this is the data set. It's kind of long, but it's listed from a decreasing order, okay, of the year. And then the average ticket price of that movie, the total gross, I think in millions, okay. Number of movies, for that year, and then the #1 movie. Okay, so this is a data set, like as a movies by year with ticket price. It shows you the year, each row represent a year, and also the average ticket price for that year, I think total gross, number of movies, and then also gives you the top rank 1 movie for that year. Okay, so rich data set. Oh yeah, it goes back to in 1980s, I guess. Okay, alrighty. So here, like I said, this is total gross in million. So sometimes people actually do not like the format. They really want to see it in the full size. So what you can do, see what we're doing here. We are creating a new array, okay, called gross in dollars instead of $1 million. So what we did is you do the movie.column and then we select, right? Remember, by doing this, we're getting it as an array. Okay? Once you're getting an array, you can do all kinds of arithmetic. So we're multiplying it by a million, like 1 is 6. So we're able to get the gross in dollars. Okay? And why we do that, we actually want to know the number of tickets sold. Okay? So in order to do that, well, we get the gross in dollars because, well, this is total gross in $1 million, but ticket price is in dollars, so we need to put in the same unit. Okay, so we get the total gross in US dollars, and then we are dividing, right, by the average ticket price. In that way, we're able to get the total number of tickets sold for that year. Okay, so again, this is like a test I give to you, so we're following this logic. But like I said, a lot of times you have to think a little bit more about what kind of stuff you actually want to return and add as a column. Okay, but regardless, you always have to think about that first and then decide and think about, synthesize the methods that we have learned in order to show that. So anyway, so what I've done here, like I said, is that we get the ticket sold and I'm trying to attach it, add it as a new column to the original data set, which is movies. Okay, so let me show you that quickly. Okay, so all the stuff that I did, we'll be able to add the new column called tickets sold. Okay? And the way that we have done it is we do calculated. Okay, we had calculated the tickets sold based on the math that we understand and use the correct code to do that. And then also use the with underscore column to attach that into the original table. Okay, of course, well, if you want a different formatting, like this is again, I guess scientific formatting, like computing formatting, but you can always like show the exact, well, you know, there's some digital, like decimal points doesn't really make sense, but you know, because that's just the average that we took once we get the number. Okay. One last thing I will do, I know we're on the top of the time, so we'll see more of this soon. One thing we could do is that the plot method can also be applied to a table if I want to plot the year and the tickets sold one against each other. Okay, so I just want to do a quick demo there. Okay, so on the x-axis is the year, that's the first input of that plot method. The second input is whatever, like here is tickets sold. So we're plotting tickets sold against year. Okay, and this already, I think, tells you a certain interesting feature, right? Slowly going up around, I mean, up to like 2000, 2003-ish, right? And then it starts to drop. Okay, so this is what we usually talk about as visualization. Okay, a quick visualization of the data can tell you something that you really want to dig into later. Okay, it doesn't tell, like it's way to summarize information. Okay, but then of course we'll learn more methods in order to do specific things over there. Okay, so I think, yeah, since we're out of time, so I'm gonna stop here. I think Jason on Thursday gonna resume with this table methods, and then we're gonna move to the next topic. Okay, so once more, all of the demos are on our course website, so I strongly recommend, I'm sure many of you are doing that already, of going over it, or even beforehand if you want, because we posted before the lecture, if you want to get a head start on that. And yeah, so on Thursday, we're gonna continue and then start the new topic. And we're gonna have a Friday lab as usual. Okay, we're gonna post it beforehand. So I know some of you want to work on outside of the lab time, but make sure that you're always checking with the coach or me or Jason to get you checked off for your participation grade. And lastly, I think homework 1 is due tomorrow. Okay, I hope everybody is making progress. And we have office hours. Jason is having office hours now, and then Like I said, starting today, the coaching hour is going to start. So make use of them. The link is different and link is on the course website. So click the right link to talk to the coaches if you want. And I have office hours tomorrow. So hopefully that can cover all of your questions about homework 1 before it's due. All righty. Okay. Sounds good. Yeah. Great turnout. Everybody's here. So
this computer. Okay. Welcome. Yeah. So we're going to pick up where we left off last time. And we want to, where we were last time is we started talking about arrays and then tables. And so I want to kind of review tables a little bit. And the reason why I want to review tables is they're the primary form of organizing data in this class. And so really this idea of a table is going to be very central to the analysis and the visualization that we do in this course. And we're using this data science package, which is kind of custom purpose built for this course. And it's wrapped around this concept of tables. And so really, we want to kind of think about our data as being organized in tables and get an understanding of the table methods. And so kind of I come at this as from the point of view of a computer scientist. And so whenever I learn a new language or a new library, I always want to think about, first of all, the syntax of the language. And for this course, we're using Python. And so that's why we're talking about variables and how method or function calls work, how naming conventions, assignment, that's kind of the syntax of the language. And then the other thing I want to know about is what are the primary objects in a particular language? And we saw we have our native types, we have numbers, we have integers, whole numbers, we have floating point numbers, we have strings. Those are all kind of native types in Python. And then through the use of this data science library class, we have this concept of tables, so objects. And in Python, the way kind of the language is used is that once you have objects, you can perform operations on those objects. And so there's a lot of operations that we can do on tables. And so we're going to take the time and really dive down and kind of see the operations provided by the data science package. What operations can we do on tables? And so just as kind of a quick review, right? The way I want you to think of a table, it's really two-dimensional data, and it's really a sequence of labeled columns, right? So each column represents some attributes. For example, for this table of states, the label that's highlighted is the abbreviation code for it. The column over to the right is the area. And so that represents kind of an attribute. And then each row is an individual. It's each, I like to think of it as its own data point. And by putting them together, we have our data from there. And so we have a couple of methods that operate on tables. So once we have a table, there's a bunch of methods that we can do. And I think actually now is a good point. I'll come back to this slide, but now I think it's a good point to kind of remind us is that, so, we're learning a lot of syntax here, and we're throwing a lot at you. And there's a lot of different ways you can manipulate and use tables. And really the best way, I really think of it as kind of like learning a foreign language. The best way you get familiar with it is by practicing, by reading and looking at code and writing your own code. And so that's where the labs come in. That's where the homeworks come in. But until you kind of get familiar and do a lot of work with the tables, it's going to take a while for all of the operations, the methods, and the names to kind of become familiar, and that's okay. And so on our course website, and it's worth kind of mentioning now, is if we go kind of to our course website, we have this Python reference. So you see the link over to the left-hand side. This is kind of the one-stop shopping of the Python and the data science library syntax in all of the operations. And so, so here's some string methods, array methods. So if you forget how something works, just come, and that's okay. Just come back to this Python reference. And here you can see all of the table functions and methods that we'll be using in the course. Okay. So that's, I just kind of want to remind you that that's there for us anytime you want it. And so if you're forgetting how to do something, there's a couple ways we can do it. You can go back to the slides and find the slides where we covered that information. Go back to the appropriate chapter in the textbook. But if you just kind of forget the syntax, coming to this Python reference is going to be the quickest way to do that from there. Okay, so I just kind of want to make you aware of that resource. And then there'll be some stuff we haven't covered yet, but that's okay. And this should cover all of the syntax or a good chunk of the syntax that we're using in the course. And so just kind of to highlight some of the operations that we're going to do on tables, right? For creating tables, we can just call the table method. And typically what we'll do is, for this course, we usually create a table by reading in a CSV file. So that's the read table method. And so we give it some pre-existing data, and it's going to populate our table for us. If we ever want to find the size, again, so once we have a table stored in a variable, then we can call these methods on our table object. And so most of the methods are going to be function calls. They're methods. They have parentheses. The size, the num rows and num columns, that's kind of the one thing that's a little different with the dot notation. There's no parentheses after num rows and num columns. All the rest of the methods that we call are actual true methods, and they have the parentheses denoting that they're a method call. The num rows and the num columns they're kind of, in Python speak, they're defined as attributes. And they're actually just data associated with the table, but you can really think of them as a method call that returns the number of rows and the number of columns. There's just no parentheses after that. So that's a little bit of syntax just to remember. With the num rows and num columns, you don't have parentheses, but the rest of the methods we will. We can refer to columns. We can relabel, and down here, kind of accessing data in a column, this is something that we're going to do a lot. And so the mental model that I want you to think of the tables is that each column it defines a particular attribute, and we can get that column, we can extract that column from the table, one entry for each individual. And when we do that with the column method on a table. The thing that comes back is going to be an array. It's going to be an array with one entry point for every member in that table. And what's nice about that, we talked last time about all the different operations that we can do on arrays. We can add two arrays together, we can subtract arrays, we can multiply, we can add. There's a lot of operations that we can do on arrays. And so typically, if we're doing some type of manipulation, or analysis on data, we extract the column that we want as an array, and then we can do all sorts of fun things like get the sum, the min, the max, pull out different items of the array from that. So that column command we'll be making frequent use of. And we can also kind of do table level operations as well. We can select some of the columns to create a new table. If we want to create a new table with a subset of the columns, we can select the columns that we want. And if we want to get rid of some columns, for example, if the data has more data than we need, the table, it's a good idea just to make things simpler, just to drop the columns that you don't need. So select will pick the ones you want, drop will get rid of the columns that you specify and keep everything else. Any questions about tables? We're going to get a lot of practice with them. Okay. So we talked about kind of the column for getting, for extracting out a particular column. We can do a lot of operations on the rows themselves. One thing that's very handy is that we can sort on a particular column. So if we had like salaries or populations and we wanted to see that table in an order of a particular row, we can sort on that. And by default, we sort the rows in decreasing order. You can add a parameter to sort by decreasing. The other thing we can do is we can take some number of rows. And the way we want to do that is we can use the take method, and you can specify the row numbers that you want. So the one thing that trips a lot of people up is that Python counts from 0. So rows have an index, and this is a fairly normal convention in computer science. When you index something, the very first element is 0. And so the way I kind of think about it is I mean, just one thing to remember is that Python, often starts counting from 0. When you index something, it's going to start from 0. And really, the way I look at it is that number is how far that element is away from the beginning, right? So the very first element is at the beginning. It is, it's 0 length away from the beginning. So just remember, we're not indexing by 1. So if you wanted the first row, of the table, you would do take 0. The where method we get a lot of use out of. That allows us to perform decisions, right? This allows us to selectively, so take will just give us the particular row number that we want. So you just specify the rows and then you get them. The where allows us to specify, we'll give a column that we want and to look at, and then we can have some conditions. In essence, what we're doing is we get to keep only the rows that meet some criteria. And there's a very, very rich set of these conditions. And if you forget what those are, the Python reference will show them. If we go down, there's a whole section on the where predicates. So we can do things equal, above, equal, below, in between or equal. From there. So it's a rich set. It can basically do all of the operations that we would want for selecting. Okay, and then the last thing, so we can use the where with these are predicates as the reference kind of specifies. There's also kind of a syntactic shortcut. If we just specify a column, and don't use this R condition. If we just look at the value that we want, if we just put a value there, it's going to do the equivalent of R equal. It's going to keep all the rows that match that value in that particular column from there. Okay. All right, let's take a look at that. So this is finishing off the demo from last time. And so remember, we always want to run our first cell. And I believe you guys did this last time. So this is creating a table from scratch. So I'll skip down here to selecting data from a column. So the first thing we do, we want to create our new table. We specify the file that we want to read as a comma separated value list, a CSV list. And then that magically reads it in the speed of light. And if we want to look at our table, we can use the show command. And this particular column, this particular table has movies shown by year and with their ticket price. Okay, so we have the year, the average ticket price for that year, the total gross, so the total number of tickets sold times the average price. So notice what is gross in. It looks like gross is in millions of dollars, and the total number of movies and the number one movie. And so it's kind of crazy how ticket prices have increased, kind of over the last 25 years. You could go see Empire Strikes Back for $2.69. That was a bargain in the day. So anyway, so that's our table. Now we have it. And so now we know we have enough tools that we can actually start doing analysis for that. And so one of the things that we may want to see is, remember the gross was shown in millions of dollars. If we want to actually see it in dollars, what can we do? Well, that's actually very, very simple. It's literally one line of code. It's one line of code. And how do we get that? So what we want to do is we want to extract the column that we're interested in, and that column has the name total gross. So we're going to extract that column. And so here, and we can do that with this movies column, right? So what that's going to do is it's going to take our table, because you notice our table is called movies. And so we can perform operations on the tables. So we're calling the column method, which will extract the column specified in its in the input to the function. So that is going to return this total gross as an array. Now, since it's an array, we can do mathematical operations on it. There's a message in the chat. Oh, sorry. Thank you. I will embiggen. Thank you for reminding me. Give me 1 second. There we go. 150% worked pretty well last time. Thanks, everyone. Sorry about that. Is that better? I will take that as yes. But please, if it's not big enough, please shoot me another message in the chat, and I'll make it bigger. So we have our column. Now that it's an array, we can do all the fun array operations that we want. And one of the things that we can do is we can convert it into dollars. If it's in millions of dollars and we want dollars, we just multiply by 1,000,000. And so instead of writing out all of the zeros, we're just using scientific notation. So this is just 1 followed by 6 zeros, which is the equivalent of multiplying everything by 1,000,000. And so now we have this array, the total number of the gross for that year in dollars. And so now if we wanted to calculate the number of tickets sold, well, we don't have that information. We don't have that information in that table, but we now know the total number in dollars, the total number of sales from there. And if we have the average ticket price, we can take this column, this gross in dollars, and divide it by the average ticket price. And that is going to give us a new array. So if you think about the types, right? So gross in dollars is an array. We're extracting the average ticket price. And remember, when we extract these columns, they're going to be extracted in order that they are in the table. And so this array gross in dollars will correspond with the average ticket price. And so it's going to take the gross in dollars divided by the average ticket price, because this is now going to be an array. So an array divided by array, that mathematical operation will work out. And that will give us the number of tickets sold in an array. Okay. So notice nothing got printed in the screen because I'm doing the assignment. And so we could look at that. We can just put ticks sold. And if we rerun that cell, we'll get the array there. But that's a little hard to visualize. So what we're going to do is, what we'll do in the next cell is we'll add it back to our table. So we're going to take our table, we're going to take our table, movies with column, and we're going to add that back. Okay. So we're using the movies with column, and that is going to allow us to add an additional column to our existing table. Or we'll create a new table, but we're reassigning it back to movies. So with column is going to add a column. The first argument here is the name of the column, and then the array to populate the data. And so now, and then we reassigned our movies table. So now what happened was we created a new table and assigned it to the same name of the previous table. That overwrites our old table and replaces it with the new table that has the additional column of tickets sold. Okay, that's a little easier to visualize than just looking at an array. But still, this part right here, this is a little hard to read. Now, if you're kind of familiar with scientific notation, you know that even though e to the 6th is 1,000,000, e to the 9th is 1 billion. So this is 1.3 billion. Is what is representing there. But can we do a little bit better? And it turns out the data science, yes, the answer is yes, absolutely. And it turns out that there is a set format method, which allows you to control how the excuse me, how the columns are being presented when you look at a table. And there's some default formatters, and one that's actually very useful is a number formatter, which will basically say, please print this column as a reasonable looking number. It is kind of the unscientific description of that. And so now if we set the formatting to the ticket sold column, now we have something that looks a little more presentable, right? And so instead of having this just decimal in scientific notation, now you can see that it's that in 2015 they sold 1.3 billion tickets from there. Okay. So this is just kind of once we have these basic things down, extracting columns, performing operations, we can create our new columns, we can do analysis for that. And of course, having things as a table is really good for kind of looking at it and deciding the type of analysis that you can do. But really kind of the theme of today is that we want to start thinking about how we visualize our data. And so this is kind of a sneak preview of some of the visualization stuff. And we'll come back and look at visualization in a couple of the other demos that we do. But there's just no way of, it's just so much easier kind of visualizing the data. And so that's why our data science library has a bunch of plotting and visualization libraries built in. And what's nice about it is that we get these really nice plots with just very little code. And so if we wanted to plot the year versus the ticket sold, it's just one line of code. It's just this plot function. And this is going to, and we'll talk more about this in some other demos, but as a sneak preview, this will give us a line plot. So if we run this here, and now we can see a really good visualization of how many tickets were sold in a particular year. And you can see kind of the movie industry kind of peaked. It looks like around 2002 and was kind of under steady decline since then. And I think we all know kind of many of the reasons why: streaming, ticket prices are getting high. And of course, now if we got the data for now, it would look very, very, very sad. But we can dive down and we can drill down. And so we can kind of see between 2000 and 2005, right? We see kind of this peak. If we wanted to drill down and look at that, we can just get this table where we're selecting between 2000 and 2005. And if you remember, how does the R between work? The R between work starts at your first argument, 2000, and goes up to, but not including, the second argument. And so this will show us all of the rows starting at year 2000 and stopping at 2004, right? Because we're going to go up to, but not including, 2005. So if we wanted to zoom in, and we can see the movies from that time and the number of tickets sold, and you can see that it really peaked, right? Just by looking at the numbers, you can see that it peaked in 2002 from there, okay? And if we wanted that particular year, we can just do the R equal to, and again, as a shortcut, if you know exactly the column that you, exactly the row that you want to select for, instead of writing out the R equal to, you can just do your column name and what you want to compare to. That is syntactically the same thing and will give us exactly the same answer from there. And what's nice about the containing, so this is this predicate clause containing, this will do a string match. But it will match a subset of it will match, it will look for a subset in a larger string. And so if we wanted to see what years had the #1 movie of any of the Harry Potter franchise, we can do that. So it's just looking that if anywhere in the title of the movie or the #1 movie title, that it has Harry Potter somewhere in there. And if you can see that, we can see that actually two of the Harry Potter movies was the #1 movie, both in 2001 and 2011. Okay, and if you wanted to take a subset of rows, we can use you remember, so the NP is the NumPy, numerical Python, and this is the array range operator. And this will give us the range starting at 2. So the rows starting at 2, but remember Python counts from 0. And then going up to, but not including 5. Okay. And so any questions about that? Make sense? Good. Okay. So that kind of wraps up our review of tables. And so let me start a new topic.